Good afternoon. My name is Ava Martellero, and I'm from Cosno High School.
And I'm Jillian, and I'm from Warmont High School. And this is our presentation on the effects of potassium and pH on the germination of Raphanus sativus seeds.
Imagine living in an apocalyptic world where there's a shortage of food and water. You may be thinking that zombies are the cause of this apocalypse, but the cause is actually way worse. This causes acid rain, and it might be getting worse as I speak.
Some background information. Environmental health is a growing concern in our world, and a factor that could be harming our environment is acid rain.
Overview. An overview of an experiment is that we're going to put Raphanus sativus seeds, or more commonly known as radish seeds, in a wet paper towel that will be placed in a plastic bag to set up to germinate. Liquid potassium will be put in the water that will be poured onto the seeds, and the pH level of that water will be changed.
The problem we decided to get into was to see how the addition of potassium and the change in pH would affect the germination of the radish seeds.
Plan of the experiment. Our original plan of the experiment was to count how many seeds would germinate altogether. We then realized that just about every single seed germinated, so we decided to change it to how many will grow to 3 centimeters in 7 days. Variable amounts. These are the amounts that were used in our experiment. So for the minus amounts, 0.3 milliliters of potassium were poured into the water, and the pH was raised to a level of 3. For the high amounts, there was 0.7 milliliters of potassium in the water and a pH level of 7. And for the standard, 0.5 milliliters of potassium were used, and the pH was at level 5. The hypothesis. If the pH is at level 7 and 0.7 milliliters of potassium are inserted into the water, then the highest amount of seeds will germinate to 3 centimeters.
Our materials. So here we have some basic materials already labeled, but I'm going to go over a few that were big components in our experiment. So first we have the sodium bicarbonate, which was used to raise the pH of the water. Next we have the potassium supplement that was added to the water to add potassium. Then the pH test strips to test the pH of the water. Citric acid, which lowered the pH of the water. And Raphanus sativus seeds. So here's our procedure video. We first filled a beaker with 75 milliliters of water. We then poured the 75 milliliters of water into a cup labeled with the correct trial. Then we added either the sodium bicarbonate or citric acid to adjust the pH accordingly. This was then mixed together to ensure that there were no clumps on the bottom of the cup and everything was mixed together well.
Statistics terminology. The first term, DOE is our first term. So a DOE is a design of an experiment that aims to explain the variance of two factors. We use a two-factor DOE, meaning that there's two factors that could change the outcome of our experiment. The independent variable is a condition that is changed by the scientist.
The dependent variables are the variable that shows your reaction. So in our case, it was the amount of seeds that germinated to 3 centimeters in the 7 days. The interaction effect is the effect that both the variables had on our seeds. So the pH and the potassium working together. Our independent variables were potassium and pH. The potassium levels would be The potassium levels would be changed by adding drops of potassium supplement to the water, and the pH would be changed by adding the sodium bicarbonate or the citric acid.
The dependent variable in our experiment is the amount of seeds that will grow to 3 centimeters in 7 days. This is written as both a percentage and a decimal.
What is pH? pH is the acidity or alkalinity of a substance. pH can be used to stimulate acid rain, and pH can have negative effects on the growth of plants.
What is potassium? Well, other than being an element on the periodic table, potassium is considered a second only to nitrogen as a plant nutrient. It is required in large amounts to stimulate plant growth and reproduction.
What are enzymes? Enzymes control the metabolic activity of an organism. Enzymes can be affected by factors such as temperature and pH, and enzymes can slow or quicken the reactions that happen in a substance. The molecules that an enzyme works with are called substrates.
In the previous slide, it was said that the growth rate of an enzyme can change very easily. So an enzyme's optimal pH is around 7, but in this animation, the pH level is 3. So when the pH is far from its optimal one, it will distort the enzyme in which it cannot fit in any kind of chemicals, so it will not grow or reproduce as quickly. On the other hand, potassium flourishes the enzyme. The potassium changes its shape so that the enzyme can grow more, and it'll grow. As you can see, the substrate fits perfectly in so that the enzyme can grow and reproduce more. The data. So it was hypothesized that our plus variable would have the highest percentage. This had an 81% growth rate. It actually turns out that the minus plus had the highest growth rate of 90.
This is a graph of our standards, and we only have 2 standards because we were not, with the circumstances, we weren't allowed enough time to do more standards. Although there were 10 seeds in each standard, and our standards do range as we have a lower standard at 0.11 and a high standard at 0.44. These were subtracted to get 0.34 for our range of standards. The range of standards to come up with our fences to figure out the effects later on were multiplied by 2 to come up with 0.69, which were then used as our fences at a negative 0.69 and positive 0.69.
The effect of potassium. The effect of potassium is negative 900. This was found by subtracting the low average from the high average. The low average is 0.7 and the high average is 0.61. So when these are subtracted, it comes out to be negative 900. The slope is not that big, indicating that there's not a big effect for the potassium.
The effect of pH. The low pH was subtracted from the high pH, so 0.45 was subtracted from 0.86 to get the effective pH to be 0.41. This also did not have a very large slope, but it is larger than the slope of the potassium.
The interaction effect of potassium and pH. The interaction effect value is 0. This means that both slopes for the low slope and the high slope both had the same slope. Even though the same slopes indicate that there is no interaction between the two, this cannot be proven.
This is a dot plot of our effects, and here we can see that none of our variables were statistically significant because they're both inside of the fence. All 3 are inside of both fences. The pH, however, did range from 0, the most, showing that the pH had a greater effect.
Hypothesis, accepted or denied. The hypothesis that states that the plus variable would have the highest growth rate was declined. The minus plus happened to have the highest growth rate.
How did this happen? It was said that with the science to back up, that the plus would have the highest germination rate. But that was not the case in our results, so it could have happened by chance or lurking variables that we did not receive those results.
So lurking variables. Lurking variables are things that happen outside of the experiment that could have affected the results. One lurking variable for our experiment was that the trials were done in different places. Even though that most of the experiment was done in Mr. Estapa's greenhouse, the seeds were taken out into both of our homes. Another lurking variable was that gases were let out around our experiment. This could have easily affected the enzymes, which could have affected the growth. And the last lurking variable is the non-consistent temperatures. Just because of the weather and the fact that they were moved around, the temperatures could have changed, which could have altered the growth too.
So to recap, even though nothing was statistically significant in our experiment, the pH did have a greater effect, so we can say that pH does have an effect on agriculture, and it appears that the potassium of pH was not a large component in our research.
If this experiment were to be repeated, I would make sure that the location of the seeds were consistent. It'd either stay in the greenhouse all 7 days or I'd take it home for all 7 days. Another one I'd change is that the potassium would be spread out more. We proved that the potassium did not have a huge effect value on the seeds. This might have been because they were too close to each other. Maybe if the potassium were spread out a little bit more, it would have had a bigger effect. And the last one is that I would have more seeds in each trial. We only used around 10 to 15 seeds for each trial. This wasn't really a lot to have accurate data. And as said earlier, we only had 2 standards. We should have had more of these too.
For further research, more experiments can be done to stimulate the effects of pH, such as acid rain on seeds, and we can experiment with using pH and other nutrients that plants need and how those work together to affect the germination of the plants.
In conclusion, the experiment went somewhat as planned. Even though that our exact variable did not have the highest effect, it still proved that pH had some effect, meaning that acid rain does affect our environment, but maybe not as fast rate as some people might say. Acknowledgements. Some adults I'd like to thank are Mr. Aker, our geometry teacher. He helped us advise all the math and basically taught us how to do all the math. Mr. Estafa, our biology teacher. He helped us with all the scientific concepts and answered our questions. And last but not least, Ms. Grabell, our IDS teacher. She helped us with formatting our PowerPoint and our paper.
These are our works cited.
Thanks for watching.
Any questions?